All right, so the last couple of weeks we have covered all the software tools that we want to use for this course. We also cover all the Python basics. And by now, you said all the building blocks that we need. So for today's lecture, we're going to start covering geospatial stuff. And the first one we're going to look into is GeoPandas. So we have already covered pandas for dealing with tabular data. GeoPandas is basically acting like geometry column. If you've ever used any geospatial data, let me ask that way. Have you ever used any GeoJSON format? File. So SSP, right? You know it. So what's the components included in the .ssp? What makes a swap file a geospatial data format? What does it have? Yeah, location data. So what's in there? What's inside? How long do you like to do? Where do you see it? So maybe let me quickly download some example. I want to make sure that you understand. I mean, why we're using geospatial data? What makes geospatial data geospatial? So if I go to maybe my GitHub repo here, and let me download a sample data set. So we can take a look at the inside the data format. I'm going to use maybe the US data set somewhere here. And there should be, okay, I'm going to use this one, US cities. Okay, the zip file, download to my computer. Then I'm going to open here, unzip it. Click here. Okay, so if you take a look at this, right, we have, oh, this one has a little bit more, but let's talk SHP here. Is it enough? Is this just the one file? Is it really SHP, talk SHP? Is it a swap file? What else do you need in order to be usable? The projection? What else? What else? Attribute, DBF. Actually, this one is optional. So TRJ, this one is optional. It's not required. What is required is doc SHP and doc DBF and doc SSX. Why? That one, this one is the spatial index. This one has the geometry. This one has the tabular data, the attribute table. And this is why it's called geospatial. So when you open the point in desktop GIS, you don't see the points, right? You don't see the coordinates. That one is embedded in the column. It's so-called the geometry column. So I can quickly maybe show you here. If you just have this one, it's not enough. It's incomplete file. It's not going to work. So you need multiple files together. And let me open Google Satellite here and drag this one to the map. Okay. Oops. You're going to have all the US cities here. You right click, open the attribute table. Do you see the points coordinates? Do you see the coordinates here? Yes or no? Where's the latitude, longitude? No, right? Most of the shape files don't have the latitude, longitude listed here. This is the point. For polygon and lines, you're not going to have the column. That column is hidden. Okay, that's the geometry column. It's not showing it on the attribute table. The attribute table only contains these columns, and it's basically this one. This is the attribute table. The geometry is in this one is the shape. The shape is not on the attribute table, and the .sh is the spatial index. Why it makes spatial data indexing so fast, because when you are trying to select by location, select by attribute, it will need this file. So this is basically the spatial indexing to point to which one. It's kind of complicated, but if you use a GeoJSON, same thing. This is pretty much the same data. Again, if you open it, you don't see the coordinate. But why the software knows how to plot that on the map? Because there's some geometry column in there. It doesn't read it out. If you use text editor, so the .ssp, you cannot open this one in text editor. But this one, you can probably open in Excel, or maybe, let me see if you can open it. This one basically doesn't contain the geometry. And You see this one? Just this. It's just a tabular data. There's no XP in there. XP is in the .ssp. And if I open this one, the GeoJSON file, so this is another commonly used vector format. This one has the coordinates inside. So they have a column. Let me see if we can zoom in a little bit. If you see, it's too much. Okay, so look at this. Coordinates, type, point, geometry. And this is how desktop.js is used to render, to plot it on the point. So GeoJSON file is just a plain text format. It can be read by any text editor. It has all the coordinates in here, but it's not embedded. And this one doesn't have spatial indexing. If you're opening a file GeoJSON that's like gigabyte, it's going to be super slow. But the advantage is that anyone can open it. You can use any text editor. You can use Python to loop through that. But for the shape file, you cannot. You need some GeoPandas to actually to read that, or some other packages, because it's binary. This is not binary. This is a simple TXT file. Okay. So there are many other data formats. Also, this one, for example, CSV. CSV contains geospatial information in there. Yes or no? No. This is just part of the tabular, the attribute table. There's no geospatial information. So these are some of the commonly used formats. Of course, you can have a column called latitude, the other column called longitude, and then you can use desktop.js to actually create a geometry based on that. And shapefile has been there for a long time. It's ArcGIS, but it's going away, okay? And try not to use shapefile. If you don't have to, it's not a good format, but it's so widely used. And I really hate that a file that has multiple parts. Sometimes people forget to copy. You send other people, and it's just saying that .ssp without other stuff you cannot open. GeoJSON is very common. For small file, you can use GeoJSON. For large file, you want to use GPKG, GeoPackage. Or you can use GeoParquet. It's more like for tabular data. We might cover some of this later in this course, but this is the common one, save as. And then there should be one called GeoPackage. So this is the preferred one. It's only one file, a single file, and there's no limit. Shapefile limit is 2 GB, but nowadays many files has like 20, 30 GB. If you're dealing with national data, it's huge. So you might want to use GeoPackage. But for ArcGIS software, they use GeoDatabase, GDB, and it's also something that's not open source. You might want to use this as like open source format. It's so much better. Also, this one here, GeoParquet. This is also a very popular one in the last couple of years. It's for like creating data on the internet, and it makes the query so much faster. We cover this one later in this course, but now they say you have this data set, but how do we handle it in GIS? How do we do that in programming? How do we read the file? How do we do some manipulation? How do we do the selection? That kind of stuff. So I'm going to open the Geospatial notebook here and open GeoPandas. This one. Okay. And make sure you install it. I'm going to select the kernel. Here, we're going to use Pandas, GeoPandas, and also Matplotlib. Matplotlib is a very popular library for doing plotting. We actually have used this one under the hood for GeoPandas when we try to create plot. Later we use some of these, but you're going to see this one many times. If you go online to find some sample code, Matplotlib is everywhere. It's probably the third most popular library. The first one will be NumPy, Pandas, and then Matplotlib. So those are the 3 popular libraries for doing data science, to processing data, creating maps, plots, but it's not interactive. So first, let's take a look at how do we create geospatial data. And we cover in the previous lecture, you can use a dictionary to create a pandas, right? Pandas data frame. And you can have longitude, latitude, you can have columns. If you want to create one to change from tabular to geospatial data, you can just turn a data frame to geodata frame. All you need to do is to provide a geometry column. And this is essentially what a shape file can be rendered in GIS is, because it has that geometry column. And that one is a hidden column. What we're using is this one, GeoPandas dot point from XY, and then passing the longitude column, the latitude column. So maybe do it this way. be easier to understand. So I'm then going to copy this 2 block here and run it. Oops, got to run the import the library. All right, so let me run this one and just show the data frame right now. Okay, so this is just a table with 3 rows and 4 columns, right? We have the longitude, latitude column. By looking at this one, is this geospatial data? Is this geospatial data? I think maybe the question is a little ambiguous. You can say yes or you can say no. You can say no because it's just tabular data. It's no, you cannot just drag this one and then just put on the ArcGIS or QGIS. It doesn't render. It's not the data format that you can use. You can save this one as a CSV. If you open a CSV in QGIS, it will just a table. There's no geospatial. You can also say it's geospatial because I have the latitude and longitude, but it's just text. It's just plain text. You can have the numbers. It doesn't mean that it's geospatial because you need to put it on the map. If you need to put it on the map, this is not sufficient. You need to do some conversion, and this is why we're using this way. So we are putting basically trying to create a geodata frame. We are putting this data frame in here, but you need to specify the geometry column. And the geometry column, this one we're using a point. So a point is represented by longitude and latitude. And then points from X, Y. So you're just passing basically these 2 columns. It's the list of these 2 columns. Then it becomes a geodata frame. So if I run this one, take a look. Now our data frame has this geometry column, and it's called point. The geometry type is called a Shapely, SSAPELY format. So there's a vector format basically dealing with geometries. Right now, excuse me, this becomes geospatial data because you have the geometry column, and if you want, you can just type gtf.explore. Just call this function, run it. You see? Now we have these points showing on the map. Okay? But where is this? What's happening? While it's a canvas, but it's like way out. There's nothing showing up. Wouldn't it be nice to have a base map beneath so you can know the location? How can we do that? Anyone knows? So the reason that it doesn't have the base map because it doesn't know where it is. You have the number, but doesn't know the projection. So this coordinate system is very important when dealing with geospatial data. How do you check the coordinate system? It will be gtf.cis. You see this? It returns nothing. That means there's no geospatial information. So what we need is this. Oh, perfect. Copilot is so intelligent. So you can change this one to EPSG 4326. Anyone would know like what EPSG stands for? European Petroleum Standard Group. I don't know why they use this, but this kind of standard. So you're going to see a lot of this in including geospatial data. So 4326, that one is the so common. It's basically WGS 84, latitude and longitude. But there are so many like UTM projection or maybe Airbus projection. So the common one will be 4326. You can search it. You can find what this one is about. Okay. So this is the WGS 84. That means this is okay. I want to make sure that you understand the differences between coordinate system and map projection. Okay. WGS 84 is a coordinate system. It's not a map projection. That means it's the latitude longitude is the one used to measure location on the globe, a 3D globe. Projection means it's flipped to the flat map. So the other one very common is 5070. Anyone knows what's this one? It's the US Connors Airbus projection. So this one is a projection. This is unwrap the 3D globe into a 2D surface. And there's some like UTM projection. There are so many things out there. Anytime you see EPSG something, but you just Google it. You know like what kind of projection it is. Later I will show you more example. But for now, They just assume, okay, this is the one. And once you have assigned a projection, run this one again. Oops. Not working. Let me on this. Find it. You see? I now have the base map. It's much better. I can just hover my mouse. Now I know the exact location. The reason is that if you don't have a coordinate system, GeoPandas doesn't know what does that represent, what kind of coordinate system that they're using. So it doesn't show you the base map. If you run this function, if you run into any errors, that means you're missing the map classify package, and you might need to install pip install map classify. If you can show the map, don't worry, that means that the dependency is already there, so you don't have to reinstall that. This is how you can easily display geospatial data on a map. Just call the geodata frame.explore function, and then that's it. You can just render it on the map easily. Next, let's talk about how we deal with reading some files, right? Here, I'm just providing a GeoJSON file on GitHub. You can use the GeoPandas read file function to read any files from the internet. If the GeoJSON format or it's a zip file on the internet, it will be able to read the file. Your zip file, if it contains .hsp, then you can read the file. So let me show you. If I run this one, it's going to go online to download the data and then show you. Anytime you see the geometry column, it's a good sign. That means it's geospatial data. So how do you see that on the map? So this one represents New York city, the counties in New York state. How do you see the map? GTF.explore. Perfect. See? Now I have the map. Very nice, right? And you have your mouse, you're going to see the color, something like that. You can actually also specify a column. For example, this is a shape area. I'm not quite sure. Let me try it. Column equal to maybe borrow name. Category 2, range equal to 2. Run this one. Wow. Cool. Very nice. See? Now I have the map. Just simply render and with different color on the map. Although it's not super clear, we have 4 borrows here. 5 actually. So just one line of code. Look at this. Explore. You can specify a column you want to use use the symbology, and whether it's numerical data or it's categorical. So this is categorical. And you can also show the legend. The legend is the one in the lower right corner here. And you don't need desktop GIS. If the data is pretty simple and straightforward, you can just use this one just to plot that. Super easy. Questions? Next, let me show you another one, right? So I have some file, for example, US counties on the GitHub, right? So I have this one. I can actually just go here, copy the URL. So if the file, the zip file contains zip files in there, you can plot it. So I'm going to come here, read this one, replace it as a zip file, and just run it. It's downloading the file and then reading it and then transform into a data frame. Take a look. So now we have this one has been read. Of course, here you don't. This is U.S. counties, and I don't want to. I probably don't want to use this because too many. So maybe I can use the state. Use the state to render it. If you don't want to use anything, just remove this. Just explore. On it. You also have the county render on the map. And this is probably a relatively large data set. It might take a couple seconds, but you should be able to see the map in here. See, now I have the counties map. Pretty nice. It might be a little bit laggy because the file is a little bit too much. If you want to change it, for example, if you color something, I can change it to maybe column equal to state. The state basically is 0, 1 all the way to 50. And what is this? Categorical equal to 2. CA. Okay, legend, I don't need the legend. But this is just for fun. You can basically, different state can have a different color when you render it on the map. So you can use the explore function to quickly plot any vector data set. If you run into errors, if it's like oops, I saw I asked it, don't give me the laser, you give it anyway. You might need to just set it to false. Okay, looks this. Not bad, right? It's just like you drag that into desktop.js and you have some of these showing up on the map. And every state is going to have a different color. Zoom in, you're going to have your mouse, you're going to have the pop up here. Pretty cool. So just one line of code. If you have the state name, it's even better. But right now we don't have that. So you can also read the file from a local computer. Earlier, I downloaded these files to my computer, right? So now I can actually have the file. I can just change the file path. So it can either come from the HTTP URL or it can come from a local file. So this one, I'm reading the US cities. Okay. This one is a small data set, so it's so quick. Of course, right now this doesn't work anymore, so I need to move it. Right. So now I have all the US cities points. You can also read GeoJSON. Same thing. I can export it. The same data format. So you can just passing a local file path. If you're on Windows, okay, make sure you put an R at the beginning. Otherwise, you're going to run into issues. It sometimes may say the file path something wrong because Windows use backward slash, right? For the file path, backward slash is an escape sign. It's a reserved key character in Python programming language. So if you have backslash, you need to have 2 backslashes. If you open, for example, on Windows, open the file path, and you just copy and paste and then put in here, make sure you put an R at the beginning. What does R stand for? Raw. That means you're going to treat as it is. Otherwise, you're going to treat as an escape sign. You're going to run into trouble because you might have some special character, escape T, escape N or something. Then it's not a file path, it's escape sign. So let me show you here, right? If I have a temporary directory somewhere here on my computer, right? And if I try to copy this one, assume that if I'm on Windows, if I try to copy this one, for example, temp or something, let's say under here, I just want to show you what happened. And without this, so on your computer, you'll be like this, backslash, okay? Backslash, 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 right? Is this going to work? No, it's not even getting into the next line. This line is already long. It's super long. Why? Because you have backslash, backslash. If you put in U, R at the beginning, it should be better. It should go to the next line. The next line, because the file doesn't exist, so you're going to show you the error. Unless you want to change all the file paths to forward slash, it's up to you. But probably you don't want to do that. So if I drag this one inside, or I have another copy, and no, now it should work. Oops, what is happening? Downloads, US cities, temp, US cities, or US cities, temp, and then US cities. Be here. Oh no, it's right. Oh, because this one I'm using on my computer, so I'm missing the first part. So I need to put also this one as well. Anyway, it's not a good sign. It's like mix of forward slash and backslash. Don't do that. Just put an R at the beginning. It will make your life easier. Okay, so once you plot this, open the file. You can save the file. Let me undo all the changes because I don't want to do all the typing. So let me close it out, and I'm going to run this one more time so I can have all the results. Import the libraries, okay, and then I can read the file from GitHub. Okay, so earlier I already covered how to use the explore function. After you do some manipulation, you might want to save the file. You can call this function gtf.toFile, and then just save it to a different format. You can give a driver if you want, but normally you don't have to specify. You just to file, you'll be able to figure out the format is needed for the file extension. So the driver basically means GeoPandas supports so many data formats. If you want to be very specific, you can provide it, but if not provided, it's going to get based on the file extension. So here, right, we have this file. We want to save it. Right now, if you look at my folder here, I don't have that file yet. So I click this one, it's generated. So look at this. So now I have this NYC borrows GeoJSON. Then I have this one, and I can certainly open this one in QGIS. So documents, books, Geospatial, and I can drag this one to the computer. Okay. Zoom. All right. So it's able to over there on the map. If it doesn't have a projection coordinate system, then it's going to struggle. Sometimes it might not display that properly on the map. Also can save as .shp. Again, here to file, we don't specify the file extension, but it works just fine. Oh, there's some errors. It's just some dependency issue. This is right now the recommended one, .gpkg. So this is the geo package format. Again, you don't really need to specify it. I personally just took to file and give a file name, it's work. Okay, so you have geo package. Where is it? Here, this one, geo package. The nice thing about this is geo package not only stores the information, but it also stores all the symbology, everything else. Because if you open a shape-file GeoJSON, every time the color changes, GeoPackage can store all the basically the layer style. So much better, right? So right now, look at this. It's green color. I'm gonna remove it, and I'm gonna open it again. What do you think the color would be? Huh? What do you think the color would be? Can you guess? If you know the answer, you will win $1 million. Oh, it's still green. That means the default one is green. It's not always the case. So let's try GeoJSON. See if it gets a different color. Where is it? GeoJSON? You see, this time it's pink. I don't know. It's random. It's a random color. But if you open the geo package, you can do some customization. You can save the layer style, everything within a single file. So it's always the same color if you want, right? So here, right now, I can open it, right? It's going to be yellow. You can make some changes, and then you can export this one back as a geo package. And you will always use the color that when you save the file. So this is how you can open the file, okay? You can use GeoPandas to open pretty much any geospatial data format, vector data from the internet or from local computer. Then you just call .explore function to plot the map easily. Next, let's talk about some of the methods that are available through GeoData Frame. So here, you can set an index. So let me show you what do we mean by index. Right now, if you look at this one here, the index is 0, 1, 2, 3, 4, 5. Sometimes you might want to use a different index. So index you can think about is a unique ID for each row. You can, as long as your data have a column that's unique ID, it's not duplicate, then you can also use that column as an index. The reason we're going to use that is index you're going to use in do all the plotting, do all the calculation, and sometimes it's better to then just use the number 0, 1, 2, 3, 5 or something like that. So you can call the function called set index borrow name. So what we're doing here is that now we want to use this column as the index instead of the number. And then we're going to calculate the area, gdf.area. Oh, by the way, so let's look at this one, gdf.cis. See? So this one is EPSG 2022-63. So this is not WGS84 anymore. Right now, this one is a projection. And it says NAD, North American Datum 83, New York, Long Island, blah, blah. So basically, this is a custom projection, Lambert conic conformal projection. And if we have this one, GeoPandas can actually render the file, render it on the map. If your coordinates is 4326, you cannot calculate the area, okay? It needs to be a projection to be able to calculate the area. So that's why we can run this one and then create an area column. Look at this. So now on the right, shows you the area. So plus 0.9, that means e to 10 to the power of 9. Basically, it's 1 million. So 1.6 multiplied by 1 million square meters. Or is it square feet or square meter? Oh, it's feet. Okay. 1.9 multiplied by basically 1.6 million square feet for each county. Your projection is 4326. You cannot calculate the area. I want to make sure you understand this. All the area and the length, all those information, you need to have a projection to be able to do that. Also, we can calculate the boundary. So the boundary is the length of the outline. You can also calculate the centroid. We run this, right? So now we have this broad name. We have the boundary. The boundary basically is just the line. And the centroid is the center, the point, the center of this. If you look at the number, at least latitude and longitude, is this latitude and longitude? No. Those are coordinates, are projection, x and y. So it's not longitude, latitude anymore. But it's because it's projection, so GeoPandas can actually render it. Right now, I'm going to show you here. If you just use gdf.explore, oops, on this one, it's going to render this one, right? Because this is polygon. And we also plot the outline, this one or this one. Keep in mind, a geodata frame can have multiple geometry columns, but you can only have one primary geometry. You can change it. So unlike Spatial, it's like if you're trying to create a Spatial in GIS, you need to select the geometry type, right? Whether it's polygon or line or point. You need to decide first. But you cannot have multiple geometries in the file. GeoPandas is different. You can have multiple geometry in that column, and you will be able to render it directly. So let me show you what do I mean. Right now, I show you the polygon here. If I just want to show the outline, because we already calculate the boundary. So basically, you can think about convert the polygon to line, and now I just want to plot the line. How can you do that? Because the boundary is already in the geodata frame. If we plot this one again, gdf.height, see that? We have the geometry, we have the boundary, we have the centroid. So that means your data frame actually contains 3 geometries. If you want this one, you can change it. All you need is gdf.set geometry. I take a look at this. Set geometry. Right now, I don't need this one. I can set the geometry to boundary and see if we can plot it. So boundary, right? That means right now this one becomes a data frame, and I can use the .explore function. Thank you, Copilot. See, I have the line now. It's not a point anymore. Same idea. I can change this one to last column, centroid. Find it. I have 5 points. And the reason for this is You can set a geometry. Also keep in mind, GeoPandas, if you change something, it's not going to override the result. It creates a new variable. So right now we use the set geometry. It does not override the original geodata frame. Your original geodata frame is still intact. So if I run this one, still the same like this one. So if you really want, right, here I can geodate GF2 equal to GDF2 and then equal. It means right now I become a new data frame. Oh, you need to if you have data frame, don't call the explore function. Just set the geometry and then GDF2.explore. And this is a better way. So you can plot points, you can plot polygons, you can plot all kinds of things. So basically, the geodata frame can contain different geometry columns, and you can decide which geometry column you're going to use. So you can have polygon, you can have line, you can have point. Isn't it fantastic? You don't have to create 3 files. All I need is just one data frame, and I can render whatever geometry I want. Super easy. You can also measure distance. So look at this one. So LOC means is location. So location means it's trying to find the line where equals to Manhattan. Right now, because I use the index. So let me show you one more time here. GTF.head. Okay. So we have this geodata frame. Keep in mind, this one right now is the index. Okay. If it is the index, we can use the .loc to get the information, to select that row. Kind of like you open this one in desktop.js, you just select one row, right? For example, how do I select this one? How do I select this Manhattan out of the data frame? If you go here, right, I can open this one, open the attribute table, okay? I can just come here, select this one, right? And it should be highlighted. You highlight it, zoom to, oops, select this one, and then zoom to the, what's happening? Where's the zoom? Zoom to, okay? So this one is being, why is it so dark? Anyway, so let me tweak this. Oh, it's because I select the wrong layer. Like this, right? So you can select it, select by location or select by attribute. Right now, let me do it one more time. So this, select Manhattan. Okay. You see, I select this one. How do I do that programmatically? Right? Assume you already have the data. I want to select this one out of the data frame. How do we do that? It's here, right? You can say, okay, just use your mouse. Just select that. And not the right way. You don't do things this way. Then it's the point of doing programming. You already have the data frame. And because you have the index, so right now it's super easy. It will be GTF dot LOC. Okay. Okay, perfect. Okay. It's actually select all the values for that row, right? The barcode, blah blah. So basically, select all the information. But if you know keep that as the centroid. For example, you want to just select particular value, then I can also have a comma centroid. Okay, and run it. Oh, yes, it is. Just show you the point because right now it's a geometry, so you can actually show you plot display that particular point. But this is a geospatial data, so it's a geometry, and that's why you can assign this one to a variable. Then you can calculate the distance of all the points, right? So here I have all these centroids. Right now I want to calculate the distance between all the points to Manhattan. So for each point, you can just call this function. So this it gets all the centroids and then dot distance because all these centroids are geometry. So the geometry has the dot centroid function, and I'm going to calculate the centroid to Manhattan. And after that, I can print out the distance. Right? So these are all the centroid of those 5 boroughs. And these are the distance. Of course, Manhattan to Manhattan centroid is 0 because it's the same point, right? But I can calculate the distance to each of you. Isn't it nice? So for example, I'm sitting here, and right now I have the geospatial data for all of you in class. I know your location, your latitude, longitude. And now I want to figure out who is the closest to me. Because you like me, you want to get extra points. Okay? And just kidding. So think about if you have the points, the data frame, right? I can just run the dot distance. And you get all the distance all together. Of course, you can calculate this one in a desktop.js, but in GeoPandas, it's so easy. Just one line of call. Get the data frame, have that same to a column, call the distance function, and then provide which one do you want, which point. If you remember in the previous lab assignment, previously, there's a question about calculating the distance between one point to the other, right? And then you have a list of points. You want to do the consecutive. You need to do a looping, and then you need to calculate this one line of code. If you construct the data frame, it will do that for you. You also consider all the projections, so you don't have to worry about, oh, is this WGST4, is it a UTM projection, or is it some kind of projection? Because it takes care of everything for you. And this is what this one is about. You can also calculate the average distance. So this one, you can grab the column. So this is right now using Pandas functionality, right? So if you remember the previous one, we open a CSV, we calculate the total population, calculate the mean, the sum. So GeoPandas, built on top Pandas, it can use all the functionality from Pandas by explode geometry operations. So in that way, you can generate the boundary, you can generate the sensor, you can calculate the distance, you can calculate the area. Pandas cannot do that because Pandas do not handle geospatial data. All right, so we are out of time. I think we continue this one in the next lecture. Okay, see you on Friday. Mm-hmm.